Now let's look at example 2. So the question is, the rate of decay of radioactive substance varies with the mass of the substance remaining, mt. Given that dm dt equals to negative km, so we have negative here because it is a decay. Where k is a constant, write a general solution of this differential equation. If the mass of the substance remaining after 12 years is half of the original mass, what is the percentage of the substance remaining after 6 years? So we are going to start with the first problem, which is we are going to obtain general solution of this differential equation here. So what we are going to do is we are going to separate the variable. So we have dm divided by m equals to negative k dt. And then what I'm going to do is I am going to integrate both sides. So integrate 1 over m, the answer is ln m. Integrate negative k with respect to t, we are going to get negative kt plus with c. And then convert ln to exponent, we have m equals to e to the power of negative kt plus with c. And then we can let a equals to e to the power of c. So now our m is equals to a e to the power of negative kt. So this is the general solution for the differential equation. Now let's look at the next problem. It states here that the mass of the substance remaining after 12 years is half of the original mass. So I'm going to let original mass as m naught. So from the question we know that after 12 years the mass is half of the original mass. So we have half times m naught. And the original mass is m naught, which is at that time t is equals to 0. So just now we have the general equation m equals to ae to the power of negative kt. So we are going to find the value of a and the value of k using these two information given here. When t equals to 0, m is m naught. When t equals to 12, m is half m naught. So let's start when t equals to 0 first. When t equals to 0, our m is m naught. And let's substitute our t with 0. So we have m naught equals to a. And then next, when t is equals to 12, our m is half of m naught equals to, and now we have the value of a. Our a is m naught, and then e to the power of negative k, and our t is 12. So we can cancel m naught and m naught. Now we got half equals to e to the power of negative 12k. And now let's ln both sides. So we have ln half is equals to ln e to the power of negative 12k. So ln half is equals to negative 12k. So press your calculator. So ln half is equals to negative 0.693. It is equals to negative 12k. So that our k is equals to 0.0578. So now we know our equation is m equals to, our a is m naught, and our k is 0.0578 t. The next problem is, what is the percentage of the substance remaining after 6 years? So now we are going to substitute our T with 6. So when T equals to 6, our mass is equals to m naught e to the power of negative 0.0578 times with 6. So this is equals to 0.707 m naught. So we want the percentage left after 6 years is equals to 0.070 m naught divided by the original mass, which is m naught, and then multiply with 100. So lastly, the answer is 70.7%.